When dealing with a campground installation featuring pedestal load centers, each equipped with a 30 amp plug connected to the A line and another 30 amp plug connected to the B line, and considering a total of 7 pedestals in the line, the selection of an appropriate overcurrent protection device is crucial. The primary consideration revolves around whether to protect the circuit with a single 100 amp 2-pole overcurrent device or single 70 amp overcurrent devices with handle ties, given that each pedestal shares a common neutral and is served by number 2 aluminum wire. The best approach is to protect the circuit with a single 100 amp 2-pole overcurrent device, and this is why. First, let's examine the total amperage. The total amperage available in this configuration is calculated by multiplying the number of pedestals by the amperage provided by each pedestal. Given that there are 7 pedestals and each pedestal provides 2 30 amp plugs, the calculation is as follows: 7 pedestals multiplied by 2, which represents the 2 30 amp plugs per pedestal, equals 14. Therefore, 14 multiplied by 30 amps equals 420 amps. This means the total available amperage across all pedestals is 420 amps. Now consider the implications of using a single 100 amp overcurrent device. A 100 amp overcurrent device is designed to handle up to 100 amps of current before tripping, thus interrupting the circuit to prevent damage from overloads or short circuits. In this scenario, a 100 amp device is well below the total available amperage of 420 amps. The 100 amp breaker ensures that the circuit is protected from excessive current draw that could potentially damage the wiring or equipment connected to the pedestals. It provides a safety margin, preventing the circuit from being overloaded beyond its safe operating capacity. Let's now analyze the alternative, which involves using single 70 amp devices with handle ties. While 70 amp overcurrent devices can offer adequate protection in many scenarios, the use of handle ties in this particular application introduces a limitation. Handle ties are used to ensure that when one breaker trips, all associated breakers also trip simultaneously. In this configuration, employing 70 amp overcurrent devices with handle ties would effectively limit the total amperage to 70 amps. This is because the handle ties force all the tie breakers to act as a single unit, tripping together if any one of them experiences an overload. This approach would unnecessarily reduce the available amperage for the campground pedestals. In practical terms, this limitation could lead to nuisance tripping, especially during peak usage times when multiple campers are drawing power simultaneously. Campers often use various electrical appliances, such as air conditioners, heaters, and cooking equipment, all of which contribute to the overall load in the electrical system. If the available amperage is artificially limited to 70 amps, it's more likely that the circuit will trip under normal operating conditions, causing inconvenience and potentially disrupting the power supply to the campers. Moreover, this limitation could prevent campers from fully utilizing the electrical capacity they expect to have available at their campsites. Now, let's discuss the advantages of using a single 100 amp 2-pole overcurrent device in this context. Firstly, it provides adequate protection. A 100 amp breaker is appropriately sized to protect the circuit from overloads and short circuits, ensuring the safety and reliability of the electrical system. Secondly, it allows for full use of available amperage. Unlike the 70 amp configuration with handle ties, a single 100 amp device allows the campground pedestals to draw up to 100 amps of current without tripping the breaker. This provides campers with sufficient electrical capacity to meet their needs, enhancing their overall experience. Thirdly, it reduces nuisance tripping. By providing a higher amperage threshold, the 100 amp breaker is less likely to trip under normal operating conditions, minimizing disruptions and ensuring a more stable power supply. In conclusion, when considering the specific configuration of this campground installation, opting for a single 100 amp 2-pole overcurrent device is the most suitable choice for protecting the circuit. It strikes a balance between providing adequate protection and allowing for the full utilization of the available amperage, ensuring a reliable and convenient electrical supply for campground users. Now, let's delve deeper into the technical considerations that support this recommendation, expanding on the factors that make a 100 amp breaker the superior choice in this scenario. Firstly, conductor ampacity is a critical consideration. The number 2 aluminum wire serving the pedestals has a specific ampacity rating, which is the maximum amount of current it can safely carry without overheating and potentially causing a fire. According to the National Electrical Code, or NEC, the ampacity of number 2 aluminum wire is typically around 75 amps to 90 amps, depending on the insulation type and installation conditions. It is essential to verify the specific ampacity rating based on the wire's specifications and the applicable NEC tables. Given the ampacity of number 2 aluminum wire, a 100 amp breaker is within the safe operating range, providing adequate protection without exceeding the wire's capacity. However, it is crucial to ensure that all connections are properly made and that the wiring is in good condition to prevent hotspots and voltage drops. Secondly, voltage drop is another important factor to consider. Voltage drop refers to the reduction in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, lights to dim, and motors to run inefficiently. In a campground setting where campers may be located at varying distances from the power source, voltage drop can be a significant issue. Using a properly sized conductor and minimizing the length of the wiring can help mitigate voltage drop. A 100 amp breaker allows for a slightly higher current draw without causing excessive voltage drop, ensuring that campers receive a stable and reliable power supply. Thirdly, diversity factors play a crucial role in electrical system design. Diversity factor refers to the ratio of the maximum demand of a system to the sum of the individual loads. In a campground, not all campers will be using their full electrical capacity simultaneously. Some may be away from their campsites, while others may be using only a few lights or appliances. Applying a diversity factor allows for a more efficient use of the available amperage, reducing the overall load in the system. While the total available amperage across all pedestals is 420 amps, the actual demand at any given time is likely to be lower due to diversity factors. A 100 amp breaker takes this into account, providing sufficient capacity to meet the anticipated demand while still protecting the circuit from overloads. Fourthly, coordination with upstream devices is essential for a well-designed electrical system. Coordination refers to the selective tripping of overcurrent devices, ensuring that only the device closest to the fault trips, minimizing disruptions to the rest of the system. In this campground installation, the 100 amp breaker should be coordinated with the upstream overcurrent devices, such as the main breaker at the service entrance. This coordination ensures that if a fault occurs at a pedestal, only the 100 amp breaker will trip, while the main breaker remains closed, maintaining power to the rest of the campground. Finally, let's address the practical considerations of using handle ties. Handle ties are commonly used to ensure that all poles of a multi-pole breaker trip simultaneously, protecting against single phasing. Single phasing occurs when one phase of a three-phase system is lost, which can damage motors and other equipment. While handle ties can provide an added layer of protection, they are not always necessary in a campground setting where the primary concern is protecting against overloads and short circuits. In this case, using a 2-pole 100 amp breaker provides adequate protection against both overloads and short circuits without the limitations imposed by handle ties. In summary, when designing the electrical system for a campground with pedestal load centers, it is crucial to consider factors such as conductor ampacity, voltage drop, diversity factors, coordination with upstream devices, and the practical implications of using handle ties. Based on these considerations, a single 100 amp 2-pole overcurrent device emerges as the best choice for protecting the circuit, providing adequate protection while allowing for the full use of the available amperage.